This video is on graphing quadratics in standard form. So we want to graph the following quadratics in standard form. We're going to take the things in standard form and use only standard form in this particular environment, and then we'll kind of check it by writing it in other forms if possible. Okay, so first, the vertex. Remember, we get the vertex by figuring out that x equals negative b over 2a. So in this case, a is 1, b is negative 12, c is 27. So the vertex is going to be negative 12 over 2 times 1. So our vertex is 12 over 2, which is 6. So the x value of the vertex is 6. Then we substitute that back in for y. So 36 minus 72 gives us negative 36 plus 27 gives us negative 9. So our vertex is at 6, negative 9. The axis of symmetry is always in parabolas that are y equals x squared plus something else x plus something else. The axis of symmetry is always a vertical line that is located right through the vertex. So that's x equals 6. The x-intercepts, we'll find those out, hopefully, if we intersect at a good spot. The y-intercept, we know that's 27. We can figure that out from the equation. So the y-intercept is at 0, 27. Point symmetric to the y-intercept, that's going to be exactly the same distance away from the vertex. So notice that the y-intercept will be somewhere over here at 0, 27. It should be the exact same distance away. So if this is 6 away from the vertex, it's going to be another 6 away from the vertex, since it is symmetric around y equals 6. So the point symmetric to the y-intercept is going to be at 12, 27. Notice that 12 is another 6 away on the other side. So now what we have to do is we can use our rule that we found with a. So if we know that we're at 6, negative 9, if we go over 1, we go up 1, since our a value is 1, so that's negative 8. If we go over 2, we go up 4. And if we go over 3, we go up 9 from the vertex. And it works equivalently in the other direction. So 5, 4, and 3. I ran out of room there. So I get negative 8, negative 5, and 0. So I can figure these out on the graph. So over 1, up 1 on both sides, over 2, up 4 on both sides, and over 3, up 9 on both sides. Notice that this ends up working out really, really, really well because our intercepts are nice numbers. So if we write this in vertex form, we know what the vertex is. The vertex is 6, negative 9, and the a value is 1. So we can say y equals a, which is 1, times x minus 6 squared minus 9. We get that from the vertex. And then write it in intercept form. We can get that by, well, since our intercepts are negative 3 and negative 9, we can write x minus 3 times x minus 9. Notice that we could also get that by factoring. So if we factored this equation, we would end up getting x minus 3 times x minus 9. X-intercepts in this problem are at 3 and 9. So 3 comma 0, 9 comma 0. So that's the first problem. The second problem is y equals negative 2x squared plus x plus 10. Let's find the vertex first. That's negative b, so negative 1 over 2a, 2 times negative 2. That's 1/4. So my vertex is an x value of 1/4 and a y value of 81/8. And that's what happens if I substitute 1/4 into the equation. Axis of symmetry is x equals 1/4. So once again, I could have a dotted line there, but since it's at 1/4, I'm going to kind of skip that on this problem. The x-intercepts, we'll deal with that in a minute. The y-intercept, we can tell, is 0, 10 from the equation, because if we substitute 0 in for x, we get 10. Point symmetric to the y-intercept, since the axis of symmetry is at 1/4, that means we go an additional 1/4 to the right. So we have 1/2 comma 10. And we can also easily write this in vertex form. So y equals negative 2, don't forget the a value, x minus 1/4 squared plus 81/8. So I could graph this using a table, but notice that everything's going to be kind of nasty on the table. I have 1/4, 10 1/8. I'm using mixed numbers, even though I normally don't use mixed numbers. I'm going to use them because I'm trying to plot points, and plotting points, it might not be easy to deal with 81/8 on there. 5/4 and 9/4 would be adding 1 and adding 2 respectively. My normal pattern is over 1, up 1, over 2, up 4. So now I'm going to go over 1, down 2. So that's 8 1/8. And then over 2, down 8. So that's 2 1/8. And likewise, I could have -3/4 and -7/4 and get the same values for y by symmetry that I would have had otherwise. That is still kind of nasty to graph because you're dealing with all these numbers that have eighths in them. I can do it, but it's not that fun. So I guess the question is there another way of graphing this that might be a little bit easier? And the answer in this case just so happens to be yes. So if I rewrote this equation as y equals negative 2x squared minus x minus 10, and I look to factor this thing, it actually ends up being factorable. So I can write this as y equals negative. I put a 2x and an x here, and then I put a 5 and a 2, and I end up with a minus and a plus. So I end up with x-intercepts at 5/2 and -2. So if y equals 0, this is true. Either x equals 5/2 or x equals -2. So 2.5 and -2 are values. Now notice that those are symmetrical around x equals 1/4. So that is really good. This works out where we get some nice answers. So my x-intercepts are -2, 0, and 5/2, 0. And my vertex is at 1/4, 10 1/8. I have a couple points there. And so I can graph it that way as well. I could write this in intercept form, and I already did by factoring it. So y equals negative 2x minus 5 times x plus 2. Third problem, y equals 1/2 times, or 1/2 x squared plus 6x plus 20. The vertex, we will do negative b over 2a. So that equals -6. So my x value of the vertex is -6. The y value of the vertex is 2. So -6, 2. The axis of symmetry is going to be at x equals -6. My y-intercept is going to be at 20. The point symmetric to the y-intercept is actually going to be on the left this time. So it's going to be at -12, 20. Writing this in vertex form, again, shouldn't be that hard. Y equals 1/2, again, don't forget the a, times x plus 6 squared plus 2. Writing it in intercept form, and the x-intercepts, well, those are actually not that bad. There aren't going to be any. It's not possible. And there are no x-intercepts. And the reason we know that that is true is because this is going to open up. Our a value is positive, it's going to open up, and our vertex is above the axis, so there's no way that that's going to work. Really quick, let's make a couple points in order to do this. So -6, 2. If we go over 1, we're going to go up 1/2. Notice the 1/2 in front. So this is going to be at 2 1/2, or 5/2. If I go over 2, I'm going to go up 2, because normally over 2, up 4, but I'm multiplying it by 2. So I end up with, these are supposed to be at halves, but it's really hard to do that on the smartboard. So just pretend like I put points there. And then over 2, up 2. If I go over 3, I'm going to go up 4.5. If I go over 4, I'm going to go up 8. So normally it's over 4, up 16. So going over 4, I go up 8, and I end up with a parabola that is wider than normal. That is graphing things in standard form. Also notice that you can convert things to other forms and use those forms to your benefit.